Hey everyone, welcome back. Are you tired of juggling raw SQL inside your JPA repositories? Well, today, we're unlocking the magic of JPQL. I'm going to show you the easiest step-by-step technique to transform any SQL query into clean, powerful JPQL. No more guesswork, just simple rules and real examples. By the end of this video, you'll be sprinting through JPQL queries like a pro. Okay, next let's talk about what JPQL actually is. Well, JPQL stands for the Jakarta Persistence Query Language. It used to be called Java Persistence Query Language, but it's now under the Jakarta umbrella. Think of it as a special language designed specifically for querying the data managed by JPA. Here's the key thing to understand. JPQL is platform-independent and object-oriented. This means you don't have to worry about the specific type of database you're using, like MySQL, PostgreSQL, etc. Instead, you write your queries in a way that focuses on your JPA entity objects and how they're related to each other. JPQL is used to query entities stored in a relational database. Although it's heavily inspired by SQL and resembles SQL syntax, JPQL operates on JPA entity objects and their relationships rather than working directly with database tables and columns. It borrows all the familiar SQL keywords: select, from, where, join. You're no longer talking to tables and columns. Instead, you write your queries against your Java entity classes and their relationships, giving you a type-safe, object-oriented way to fetch data. So, why bother learning JPQL? Well, it offers several key advantages. Firstly, abstraction. You work with your familiar Java entities and their attributes, not directly with database tables and columns. This makes your code more readable and maintainable. Second big advantage: portability. JPQL is part of the official JPA specification, which means your queries work across different JPA providers and even across different databases, without crazy changes. How cool is that? Now, type safety. JPQL gives you compile time checks thanks to your Java entities. This means fewer runtime errors and more confidence in your code from the get-go. And last but not least, the object-oriented approach. JPQL is all about thinking in objects and their relationships, not just rows and columns. It's a natural fit for any OOP enthusiast. Let's start with the fundamental building block of any query, the select clause. In JPQL, the select clause specifies what you want to retrieve. Alright, look at the select syntax on my screen. First, we have the select keyword, just like in normal SQL. Next up, take a look at the from keyword. You'll notice, it's just like SQL. Now, check out this highlighted part. This is where we specify the entity name. In simple terms, the entity name refers to the name of our entity class. For instance, if we created an employee entity, you'd write the employee class name right here. Now, after the entity name, we have the entity alias. Think of it as a nickname for your entity, so instead of typing the full class name every time, you can just use a short, simple alias. Same as how we give aliases in regular SQL queries, this is just a way to make your JPQL queries more concise and easier to work with. Now, look in between the select and from keywords, you see the entity_alias written there, right? Exactly like the alias we used after the entity name. Here, you need to use the same alias name that you specified right after the entity name. This tells JPQL that we want to retrieve all columns defined in the entity class. Alright, let's understand this with a few examples. Now, take a look at the screen. As you can see, we have the employee entity here. We've already specified everything, like which table and columns this entity is mapped to. So, I'm not going to add the table structure separately, because it's all neatly defined within the entity itself. Now, on the screen, you can see two SQL queries. One is without using an alias, and the other one is with an alias. Both of these queries are fetching all the data from the table with all the rows, just like we expect in a regular SQL query. But now, let's take it to the next level. We're going to convert these queries into JPQL. Take a look at my screen. In JPQL, the select and from keywords are copied exactly as they are from the SQL query, but the rest is still left empty for now. We are maintaining the same structure with select and from as in SQL. Now, let's take a closer look right after the from keyword. In the SQL query, after from, we have the table name, the one we've defined in our database. But in JPQL, As you can see on my screen, instead of the table name, we specify the entity name. In our case, I've used employee, which is the name of our entity class. And here's something important. In JPQL, the entity name is case sensitive. So, if your class is named employee, you need to use exactly that in your query. Don't forget to match the case exactly as it's defined in your class name. Alright, now let's move ahead. After employee, like in SQL Query 2, we have the alias name for the table. In the SQL query, we specify the alias right after the table name. And similarly, in JPQL, we also define an alias name for the entity. This alias acts like a shorthand or a nickname for your entity, so you don't have to keep typing the full class name every time. And here's the cool part. You can give your alias any name you like. It's totally flexible. For example, if we wanted, we could call the alias E, or EMP, or anything else that makes sense to you. Now, let's talk about the part between the select and from keywords. In SQL Query 1, I specified a star, which means we want to fetch all the columns from the table. Then in SQL Query 2, I used the alias name with a dot and star, like emp.star, which essentially means the same thing. We want all columns, but this time from the table alias we defined. But here's the cool difference in JPQL. You don't need the asterisk or the dot notation. You simply specify the alias you defined after the entity name. That's it. So, if you've used EMP as your alias for the employee entity, you can just write EMP in the select clause, and JPQL will fetch all the columns from the employee entity. Alright, now that we've covered how to convert our SQL queries into JPQL and fetch all the columns, let's talk about when you need to fetch specific columns instead of everything. So, let's say you don't need all the data from an entity, but just a few selected fields like employee ID and employee name. As you can see on my screen, there are two SQL queries fetching values from the employee_ID and employee_name columns, one without an alias and the other with an alias. Now, the JPQL query is also on your screen. If you pay attention, you'll notice that most of it has already been converted according to what we learned earlier. What we'll focus on now is discussing what should appear between the select and from keywords in JPQL. Everything else we discussed earlier remains the same. Now, between the select and from keywords, let's say we don't need all the columns, but only some specific ones. If we wanted to fetch all columns earlier, it was easy, right? We simply used the alias name and that's it. But now we want to get only certain fields. So, how do we do that? Here's the deal. All you need to do is specify the alias name, the short nickname for our entity, followed by a and then the field name of the column you want from your EntityManager. Now, just like in a SQL query where we specify multiple columns by separating them with commas, we do the same thing here in JPQL. We separate multiple fields using commas. Take a look at the screen, and you'll see this clearly. We're trying to fetch the employee_ID and employee_name columns. So what we do is use the alias EMP, the short version of our employee entity, followed by .employeeID and then EMP to employee name, separated by a comma. So simple, right? Writing JPQL queries doesn't need much. All you have to do is, where you had the table name, just replace it with your entity name. Where you had the column names, use the corresponding field name from your EntityManager. And of course, the only extra thing is the alias, your entity's nickname. One more thing to remember, field name is also case sensitive. Okay guys, look at my screen now. If we run this query through EntityManager, it's not going to work. Why? Because in my entity class, there's no matching constructor for the selected fields in the query. Here's the thing, EntityManager needs a way to map the results from the database to your entity. If the JPQL query is selecting specific columns, but the entity class doesn't have a constructor or a method that can accept those fields, EntityManager won't know how to map the result properly. One more thing to keep in mind, the order of fields in the constructor must match the order of columns in the JPQL query. If your query selects employee ID and employee name in that order, then your entity's constructor should also expect those fields in exactly the same order. So, if the constructor in your entity class expects the parameters in a different order, it won't work. Order matters when you're mapping query results to your entity. Alright, so I've added the constructor to the entity in the same order as the fields in the query. Will it work now? No, it still doesn't work. Why? Now listen carefully. In my constructor, the employee ID field is a primitive type like long. But JPA, when it tries to map query results, expects the wrapper class type, like long instead of long, integer instead of int, and so on. That's why the constructor doesn't match, and JPA throws an exception. Alright. Now if you want this query to work with the same constructor we just added, then just look at the screen. You'll see the updated query that works perfectly with this constructor. In this query, we're simply telling JPQL which constructor to use, just like how we normally create a new object in Java. Using the new keyword. In the same way, in JPQL we use new and pass all the selected fields into a constructor. Basically, whatever fields you have selected, you just pass them inside the constructor right after new. That's it. It feels exactly like you're creating a new object inside your query. So, what did we learn? Converting a SQL query into JPQL is actually super simple. You just need to replace the table name with your entity class name, and replace the column names with the corresponding field names from your entity. That's it, nothing fancy, just a clean mapping from SQL to the object world. Now, suppose we want to add a filter to our query. Look at my screen. You can see both the SQL and JPQL versions side by side. They're almost identical. The only difference is that we've swapped table names with entity names and column names with field names. I think it's pretty straightforward now, no need for any deep explanation. Now, on my screen, you can see a join query. It might look similar to a normal SQL query, but there's one important difference. In a traditional SQL query, we explicitly define the join condition to link tables. However, in JPQL, we don't have to define the join condition explicitly. Why? That's because in JPQL, we define the relationships between our entities when we create them. These relationships are automatically used by the JPA provider to generate the correct SQL joins for us. So, when we write a JPQL query, we don't need to manually specify the join condition. It's inferred from the entity mappings. If you need to add any additional filters or conditions, you can still do that just like in SQL, by using the where clause in JPQL. You can add any extra conditions on top of the implicit joins as needed. If anything was unclear, don't worry, we'll be doing all of this in the code, and you'll see how it works step by step. Thank you for watching, and in the next video, we'll learn how to fetch data without any filters, and also how to add filters to your queries. Make sure to subscribe, hit the notification bell, like, and comment below if you have any questions or feedback. See you in the next video.